Hello friends, in today's question, the system shown in the figure is given an acceleration A towards left. Assuming all surfaces to be frictionless, find the forces on the sphere. So this is a sphere and it is placed on a object which is given an acceleration A towards the left direction. Okay. So, and it is supposed to find out what are the forces on that will be acting on the sphere. So let's draw a diagram of with respect to sphere which represent all the forces. So this is a sphere and it is resting on a wedge like this, and the angle of this wedge is given as 30 degree, and so you can say that there will be a force mg that will be acting vertically downwards. This will be mg, okay. And because of this slope there will be normal acting, so we can draw the normal like this. Let us suppose this is n2 n1, we can divide this n1 into two components. This will be our, let me draw the other one also first. This angle will be 30, so we are going to have n1 sine of 30, and this will be n1 cos of 30, and there will be another normal because of this vertical which will be acting in this direction. Let us call this as n2. Okay. So these will be some of the forces, or rather we can say all the forces which will be acting on this sphere. Okay. So we can say that let us call this as A, this is B, and this is C, and this is D. Okay. So you can say that because of slope AB, a normal n1 will be acting on the sphere, so this normal you can say which can be divided in two components. Okay. And we are going to take this is our x-axis and this is our y-axis, two components which can be divided into two components. So we have in x direction we are going to have n1 sine of 30, and in y direction we are going to have n1 cos of 30. Okay. Now next will be because of this vertical wall BC, because of vertical BC, a normal n2 will be acting on sphere along x-axis, along x-axis, okay, but we can say towards left, towards left. So now finally there will be a weight mg in the downward direction. Okay, so this is our first part, second force, and the third will be, we are going to have mg in downward direction, downward, acting on the sphere. So broadly we can divide all the forces into 3. Now we are going to solve it by using simple combining the vertical as well as horizontal component. Okay, so we can say that in forces in x direction, okay, or simply we can say summation of f of x. So, and there is a acceleration of in the x direction also, okay, towards left. You can say n2 minus n1 sine 30 is going to give us a acceleration of ma, okay, where m is the mass, and you can simply forces in y direction, so you can write forces, let us call this as equation 1. Equation 1, this is equation 1, and we can say forces in y direction, that is summation of f of y. So we can say we are going to get this as n1 cos of 30 minus mg is equal to 0. And let's make this equation number 2. So if we solve this further, you can say that our n1 will be equal to mg divided by cos of 30, and if we put value of cos of 30 and solve it, this will be giving us n1 as 1.15 mg. So this is the first force, that is normal n1, and from equation first you can write, from equation 1 we get n2 is equal to ma plus n1 sine of 30, and we already know n1 is 1.15 mg. We put here, we write this as n2 is equal to ma plus n1 is 1.15 mg, and sine of 30 is 1 by 2. From here we write n2, okay, so we put value of n1, that is 1.15 mg, sine 30 is 1 by 2, For taking m as common, we get A plus 0.58 G, and this is the second normal, and the final force will be obviously mg acting in the downward direction. Okay. So we have three forces total, N1, N2 and mg in the downward direction. So you can write forces acting on the sphere, first is our N1, which is equal to 1.15 mg. Second is N2, which is equal to m into A plus 0.58 G, and finally third is mg. Okay. So these are the three forces. Thank you. These are three forces. Thank you.